Hello, in this video I'm going to talk about models of oligopoly. It will follow sections 3 and 4 in chapter 11 in the text. First, let's look at what we've discussed so far. We've looked at three industry models: the competitive industry, the perfect competition model, the monopoly model, and the model of monopolistic competition. And today it's time to fill in the gap and introduce the fourth kind of industry that's called oligopoly. And so let's see what we haven't covered so far. So far we've covered basically two situations. One in which the number of firms in the market is large, and so that case follows either into a competitive industry or a monopolistically competitive industry, depending on whether firms produce identical or differentiated products. So that is large number of firms, very little market power. And the second situation that we looked at is a single firm with a lot of market power. That is the case of a monopoly. And the gap that we're going to fill in today is a situation when there are only few firms, but those firms are large. So they have some market power, but not all. They're not a monopolist that rules the market, but not a competitive firm which is forced to take the price that the market dictates. So there will be few large firms in oligopoly models, and there are multiple models that investigate different kinds of oligopoly settings. And in some models, the products that the companies are producing are identical. In some cases, they will be differentiated. Doesn't matter for now. Just we're gonna talk about the a big group of oligopoly models. The important feature that they all have in common is that firms are able to set their own prices, so each firm is facing a downward slope in demand, and there will be barriers to entry. What could be a good example of an oligopoly industry? Think about cell phone carriers. There is Verizon, there is AT&T, and there are smaller carriers, but if you were to compete with these companies, you will have to come up with your own mobile network, and it's super expensive, so it's a huge barrier to entry. Think about airlines. There are only a few major airlines in the United States, and again, if you want to fully compete with existing airlines, you will need a fleet of aircrafts, and this is going to be also super expensive to do, so it's a huge barrier to entry. Or think about, I don't know, garbage companies in Sioux Falls. There are maybe 2, 3, 4 of them, and again, it wouldn't be that easy to enter that market. So in some cases, products are completely identical, so if a company picks up your trash, it doesn't matter which company does it, they do the same. They offer the same service. If you're flying on an airline, on the other hand, the products are slightly differentiated because different airlines tend to provide different amenities sometimes. If you're looking into cell phone companies, it's also slightly differentiated, but you get the idea. The major thing that all oligopolistic industries have in common is that there are a few large firms that control the whole market or most of the market, and they are able to set their own prices. But of course, they cannot ignore the strategies that other companies in that market are using. So oligopoly was left to the very end because it is a more complicated market structure to analyze. In the case of a monopoly, there is a single decision maker, so you don't need to take decisions of other competitors into account because there are none. In the monopolistic competition and in the competitive markets, there are competitors, but you're sort of in isolation because you just have to make your own decisions, and the decisions of other firms do not explicitly affect you. And it is the oligopoly where you need to seriously consider what your competitors are doing, and you need to try to figure out what the best thing to do is, given that your opponents are also trying to do the same. So we'll look into one model of oligopoly today, but before we jump into an analysis of a strategic interaction, let's look at the two basic building blocks for any oligopoly model. So we'll look at two basic models of oligopoly, and the distinction is firms can compete in quantities or they can compete in prices. And the distinction here is as follows. I'm going to focus on the competition in prices first because it's more intuitive than competition in quantities. So for competition in prices, this kind of model best works when each firm has enough capacity to serve the whole market. So for example, think about Verizon being able to offer cell phone services to everybody in the United States, or think about any garbage company in Sioux Falls being able to serve the whole of Sioux Falls if competition were absent. So if that is the case, then firms would simply compete with each other in prices by trying to offer the best price to every consumer. Competition in quantities, on the other hand, relies on capacity constraint. Each firm can only serve a fraction of the market even if it produced at full capacity. So in this case, you're not trying to capture the whole market, you're just trying to get a fraction of it, but depending on how much or how little you produce, you'll be getting different market prices, and thus the outcomes will be different. That is the essence of the difference of the two models. And again, let me emphasize, these are just the two building blocks, because in some situations you can imagine that the competition between companies takes place both in terms of quantities and in terms of prices pretty much at the same time. Now, let's move on and look at how competition prices works. Firms compete by setting prices, and a firm with a lower price gets the market. Think about trying to sell an item on eBay. You compete with other sellers, and whoever offers the lowest price gets to sell their product first. For competition in quantities, firms choose how much quantity to produce, and the total industry output, the total output by all firms together, determines the market price. So here, think about oil-producing companies, and their decision on a daily basis is how much oil to extract from the ground, and if a lot of oil is produced on a particular day, then the price of oil is going to be low, and if very little oil is produced, then the price is going to be high. So here, no single country, no single oil producer can cover the whole market demand for oil, but their decisions of how much or how little to produce will determine how much or how little supply there is, and thus how high or how low the market price will be. When it comes to the predictions of these two models, for competition and prices, the prediction is that, at least with identical products and identical costs, the competition between even two sellers will result in price equal to the marginal cost. That means if only the company that sells at the lowest price possible gets the market, then the firms will try to undercut each other by reducing price as much as they can. And the end point in this price competition is they will stop when their price equals marginal cost and they can't reduce the price even lower. So that is the situation. Even with two sellers that compete in prices, the outcome will closely resemble the perfectly competitive outcome when the market price will equal the marginal cost of producing the last unit. So this is kind of a hopeful outcome, that even with two sellers, price competition between the two results in an efficient outcome. When it comes to competition in quantities, no matter how many sellers, how many producers there are, and the outcome is that the price is going to exceed the marginal cost, and there's going to be some inefficiency in the market. But again, I'm not going into much detail here. I'm just trying to compare two different models, and if you were to take an intermediate microeconomics class, you will study them into more detail. Next, let's look at an example of a model of competition in quantities. And so I'm going to look at a toy situation that is not very realistic, but it should give you the idea of how you can turn real-world situations into strategic interactions that can then be analyzed using the tool of economics. So here's the setup. We'll have two airlines that will offer a flight each from Sioux Falls to Chicago on one particular date. And these airlines need to decide how many seats to offer on the flights. So basically, they choose between a low capacity or a high capacity airplane. If you've flown from Sioux Falls to Chicago, that you would know that sometimes the airplanes are quite small, and sometimes the airplanes are relatively large. So this is clearly a decision of an airline how big an airplane to offer on a particular date, and we'll pretend that the airlines make these capacity decisions simultaneously and independently. Basically, simultaneously here means that they have to make that decision without knowing what their competing firm is going to do, and independently, that means that they cannot coordinate their decisions. And so when we analyze a situation like that, we can use a table to list all possible strategies, all possible decisions that each airline can make. And I'm going to draw a table for you. And with just two companies, it's convenient to put one company on the rows and the second company on the columns, so that for each intersection for each row and each column, we'll have a cell that corresponds to the outcome that will emerge in the market if the row company were to take their row strategy and the column company were to take their column strategy. So for example, in this particular game with two airlines, each airline chooses between two strategies, a low capacity airplane and a high capacity airplane. So there are four possible outcomes. One where both choose low, one where both choose high, and two outcomes in which one chooses low and the other chooses high. So again, with two firms, it's convenient to represent their choices, their possible choices in a table, with one firm choosing the row as their strategy and the other firm choosing the column as their strategy. And what goes inside the cells of the table are the payoffs to each firm for each choice of strategy. So I need to specify how much profit each airline gets in case they both choose low, how much each company gets in case they both choose high, and how much they get in case one chooses high and the other one chooses low. And so I'm going to now fill in those cells in the table with numbers. So first, let's assume that when both choose low, every company is able to earn 1,800. And when both choose high, every company is able to earn only 1,200. The assumption here being that if you jointly offer low capacity airplanes, then the market supply is going to be low and you're able to charge high price for the airline tickets. If both companies offer high capacity airplanes, then they can jointly offer high supply in the market. The price is going to be low, and so they won't be able to make as much money. They're going to sell a lot of seats, but the price is going to be quite little. And then for the remaining two cases, I assume it's going to be symmetric, and the company that offers a high capacity airplane when the other company is offering a low capacity airplane is going to make $2,000, and the company offering a low capacity airplane when the other company is offering a high capacity airplane is only going to earn $800. So if you have one high and one low, the total supply is still going to be relatively high, so the price is going to be small. And if the price is small, it doesn't make much sense to offer a low airplane, because you'll be selling a small number of tickets for little prices. So now I've filled in the table, and just to make sure that you understand the way I did it, I'm going to color code things. So I'm going to say that airline A is going to be the blue airline, and the payoffs to airline A would be the first number in every cell. So the convention here is that the row firm will get their numbers put down first. So for low, it's going to get 1800. For high, it's going to get 2000. For low, high, it's going to get 800. And for high, it's going to get 1200. And similarly, airline B is going to be the red airline, and so the red payoffs correspond to the payoffs of airline B. And the standard assumption is that both airlines know each other's payoffs, so they can each basically sit down and look at the same table, but they have to make their decisions independently. And the second crucial assumption is that although they know the payoff of the competing company, they only care about their own payoff. So airline A only cares about maximizing the blue payoff. Airline B only cares about maximizing the red payoff. So then the question is, how should they choose their strategies? And let's first put ourselves in the perspective of airline A. From airline A point of view, the best way to analyze this strategic situation is by looking at what is the best thing to do for every choice of airline B. So let's focus on one such particular choice. Airline A would say, what if airline B chooses low? So suppose for some reason we'll know that airline B chooses low. So I'm going to get rid of all the information that is irrelevant. I just know that airline B chooses low, and then in that situation, what would the best thing for airline A to do? And in this case, airline A would say, well, high is better than low because it offers 2000 rather than 1800. So let's underline 2000, and the answer for this question will be better choose high in response to airline B choosing low. Again, airline A doesn't know what airline B is going to choose, but were B to choose low, the best thing to do would be to choose high. Next, let's ask the same question for B's choice of high. What if airline B chose high? Then again, we need to compare two numbers, 800 and 1200. Clearly, 1200 is larger, so airline A should choose high if airline B were to choose high as well. So the principle here is, once you come up with a table that describes the payoffs for all combinations of strategies of all firms, for every strategy of your opponent, you need to figure out the best response. And then we underline it for convenience. So for every column in this table, we need to underline the best payoff for the role player. Similarly, we have to do that for airline B. For every row, for every decision of airline A, we need to figure out what the best response of airline B is going to be. And so, for example, when airline A chooses low, the best response for B is going to be comparing 1800 and 2000, so high is better. So that's going to be the best response. And when airline A is choosing high, we're going to focus on the red payoffs in the second row, 800 versus 1200, so 1200 is better. So airline B is also going to choose high. And so the summary of this analysis is that no matter what your opponent, what your competing company is going to do, it's always better to choose high. So then both airlines are going to choose high capacity airplanes, and they're going to end up in an equilibrium where each chooses high and each earns $1,200. Now, in general, an equilibrium is going to be any cell in a table in which you've underlined both numbers. In an equilibrium in a strategic interaction, every firm has to choose the best response to other firms' strategy. And this is indeed the case here because High is best response to high. Other cells in the table will not be equilibrium cells because if for any reason the firms ended, say, in a situation where both choose low, at least one firm will have an incentive to change its mind. If both were to choose low, airline A would have said, well, I should have chosen high because knowing that B chose low, I would have gotten more by deviating to another strategy. Whereas if both chose high, nobody can say that we could have done better by deviating from our choice. But the interesting thing that you can see from this analysis is that high-high is an equilibrium, but it's not as desirable by both airlines as this set of strategies low-low, which is not an equilibrium. So low-low is efficient, but not an equilibrium. High-high is an equilibrium, but not an efficient outcome. And so the question here is then, can the airlines do better? How can these airlines get into the efficient outcome when the equilibrium outcome is an inefficient one? And this is the basic, this is the most interesting part of the analysis, because in many situations in economics, you see that the equilibrium outcomes, the outcome that results from self-interested behavior of the agents or firms involved in the strategic interaction, is not the best outcome that all the agents or firms would have preferred. And so the question is, well, can we somehow think of a way to induce an efficient outcome in place of an equilibrium one? And one way to think about it is, well, you know that sometimes firms try to coordinate their prices and outputs explicitly, and this is called a cartel, when airline A and airline B would just explicitly agree to choose low capacity airplanes, and thus they will explicitly reduce the supply in the market in order to get a higher profit. And fortunately or not, this is legal. So in the United States, companies cannot make agreements that will restrict supply and increase their market power. Worldwide, this is not illegal. So if you go back to the example of oil producing companies, they do operate as a cartel, although not a very successful one, but they constantly try to coordinate their output decisions so that the price of oil does not fall very low and they make decent profits. A different way, though, of getting into the efficient outcome is by putting things in a perspective. If this were a one-shot interaction between the two airlines, there is no way to get to the efficient outcome. It's not an equilibrium of a one-shot interaction. But by putting things in a perspective, by thinking about the airlines interacting repeatedly on one and the same route day by day, we can think of what is called a repeated game where, say, day one, companies have to choose which aircraft to use, and then in the next day, companies have to choose which aircraft to use, and the day after, companies have to do the same. And when the interaction is repeated, although low-low is not an equilibrium for a one-shot interaction, we can enforce low-low as an equilibrium in the competition between these two airlines by coming up with more sophisticated strategies. And an example of such a sophisticated strategy would be if both airlines agree to play low, they should just stick to playing low. And whenever an airline deviates to playing high, the other company will punish the defector by playing high from then on. So low-low is not an one-shot equilibrium, but it's a good strategy if you think about the perspective. And so let's compare the payoffs. If the companies agree to play this cooperative strategy, then playing low in every period, in every day, gives you a payoff of 1800. What happens if you decide to cheat on the other company in this strategy? Remember, you can't explicitly write down a contract between the two companies saying, well, let's play low, because explicit coordination is illegal. But if you run an airline and somebody else runs a different airline, and you realize that you're losing $600 just simply by not coordinating your efforts, you might do so implicitly without any explicit contract. And you might even stick to that implicit strategy without any communication at all. Because by cooperating, you get 1800. And if one company cheats and one company defects, the best that they can do is they can earn 2000 one day, the day that they decide to choose high when the opponent chooses low. But in every subsequent day, the opponent is going to punish them by choosing high output themselves, and so the best that they can do is get 1200 from then on. So then you should think about it the following way. If you cooperate, you earn 1800 every day. If you defect, you earn 2000 the day you defect, and from then on you start earning 1200 only. And so the question is getting $200 on the first day worth losing $600 from then on? And the answer is, if you're patient enough, it's not. And this is why this cooperative strategy of playing low can be sustained as an equilibrium in a repeated interaction. So to sum things up, this is just a toy example of an interaction between firms in an oligopolistic environment, and there are many more components to that interaction when it comes to companies in the real world. For example, the airlines can first choose whether to use a low or high capacity airplane, and then they can still compete on prices given their choices of the airplane capacity. But as a building block, this is an important one because it emphasizes that a one-shot equilibrium need not be efficient, but you can restore efficiency in a repeated interaction by enforcing cooperative behavior through a threat of punishment.